Hello class, today I'll be piloting a new video format for home-based learning with self-recorded teaching video. To engage you, I'll be represented by a dog in the corner and it's one of the free avatars available. Without further ado, take out your notes and feel free to pause the video at any point to annotate your notes. In this video, we'll be covering the free body diagrams in 4.2. Now, what is a free body diagram? It is simply a representation of an object, typically drawn as a rectangle or a circle. You may have seen some examples before. They use arrows to represent forces acting on it, and it's extremely useful in solving questions. For instance, in this example of a man pushing a box, we can represent the box with a square. Now let's draw and label the forces acting on it. First, we have the applied force by the man on the box. Then we have the weight acting on the box. Next, we have the normal contact force by the ground. And lastly, we have friction by the ground, assuming the surface is rough. Do take note of some important pointers for drawing a free body diagram. It is very important that you go and annotate the points in this slide. Arrows of the diagram represent vectors, whereby the length represents the magnitude and the arrow tip represents the direction. Next are some pointers for individual types of forces. The weight is always drawn from the center of gravity acting downwards. Normally, it is in the middle of the object unless otherwise stated in the question. Next, friction being a contact force must be drawn acting at the surface. And lastly, the normal contact force is always drawn perpendicularly, which is 90 degrees to the surface. Now, let us look at the example of an apple falling from a tree. In this case, we can represent the apple with a circle. Now, stop the video if you need some time to think about how to draw. Okay, if you are ready, you have thought of two forces, weight and air resistance. The weight will be drawn from the center, acting downwards, and the air resistance should be drawn acting upwards since it opposes the falling motion. And take note that the air resistance should be drawn at the surface of the apple, or in this case, the circle. Now, we will look at another challenging example of an aeroplane flying horizontally in the air. Okay, stop the video if you need some time to think about the answer, but there's a hint. There are 4 forces present on the aeroplane. Okay, now for the answer. Similar to the previous example, we have weight as well as air resistance. Okay, in this case, the air resistance will be going backwards since it's opposing the plane's forward motion. Now, the next two forces are something you may not have learned before. For the case of an aeroplane, the wing going under the wings will produce an upwards lift force due to something called the Bernoulli's principle, if you like to research more. Additionally, you will have a forward thrust force due to the air being ejected out by the engine, causing the plane to propel forward. Okay, now we will look at the worked example in the notes. In this example, we have a car traveling on a level road at constant speed. Draw the free body diagram of the car. Likewise, stop the video and resume the video once you have tried the question. Okay, you should be able to label the weight as well as the air resistance and friction acting on the car. Since the car is traveling at a constant speed, there must be a forward engine force which opposes the air resistance and the friction. Lastly, we have the normal contact force acting by the ground onto the 2 tires. Take note that you should be drawing the two normal contact force, as the 2 tires are the point of contact between the car and the ground. Okay, and the very last point of this video is that since the car is moving at constant speed, there should be no resultant force due to Newton's first law, which states that an object that remains at rest or at constant velocity should have no resultant force acting on it. Hence, since the magnitude of vectors which are represented by the length of the arrows, alright, hence the sum of the opposing arrows should be the same. Okay, we have come to the end of the first video. If you have any questions, please ask me during our next lesson. See you.